This is the first lesson in Mod 7 Unit 2. In all of this unit, we're going to deal with the study of rational functions or rational expressions. And that is just another way of saying algebraic fractions. We are going to be dealing with the fractions made up of polynomials. The first thing that we look at in this particular lesson is the domain of a function. Domain of a function is a set of all numbers, so it is the collection of numbers that can be substituted in the place of the variable. What can go in the place of, I might say letter X, but as we look through this, you'll find lots of different letters. All right, let's take a look at a sample problem. Number 1 says, find the domain of the rational function, and it has it right here. This is a rational function because it has a numerator and a denominator. When we talk about the domain, we're saying what numbers can we put in the place of t and we will get a valid number, a real number. Well, we could put in 1 or 6 or 3,000. So instead of thinking about everything we can put in, let's talk about what we can't put in. Fractions have a restriction. Their denominators cannot be 0. So the expression 5t, which is the denominator, cannot be 0. So let's go ahead and solve this inequality, but we solve it just like an equation. Divide both sides by the coefficient 5, and we end up with t cannot be 0 divided by 5 is 0. If t is 0, because it says it's not supposed to be, if t were 0, 5 times 0 would be 0. You would be dividing by 0, and that's undefined. So the answer, the domain is, this is red, the set of all t's such that, vertical line is red, such that t is a real number and t cannot equal, whoa, that was interesting, cannot equal 0. You're finding what I like to refer to as the domain restriction. You can plug in any number you want to. It might give you a easy fraction to work with. It might give you a nasty looking fraction to work with. But you can plug in anything you want except 0 because that will make it undefined. Number 2, find the domain of the rational function. Once again, the denominator, 14 minus x, cannot equal 0. So let's solve this. Most people would subtract 14, so x cannot be negative 14. I'm sorry, negative x cannot be negative 14 because its sign needs to go down with it. Divide by negative 1. X cannot be 14. Think about it. If x is 14, 14 minus 14 is 0, and that is undefined. So x is any real number, but x cannot be 14. You're finding what x cannot be. The next one, find the domain. 4x plus 1 cannot equal 0. Subtract 1. 4x cannot equal negative 1. Divide by 4. Divide by 4. X cannot equal the fraction negative 1/4. And it doesn't matter whether you have the negative out in front of the 1 or in front of the fraction or even in front of the denominator 4. So negative 1/4. That is the domain restriction. If x were negative 1/4, 4 times negative 1/4 would give me negative 1. Negative 1 plus 1 is 0, and that is undefined. You cannot divide by 0. Now the last one makes us work a little bit harder, and you're going to use some of the skills that you learned in the first unit of this module. Once again, the denominator cannot equal 0. This is a third degree polynomial. I need to factor it. It's equal to 0. If I factor x out of that, because I have a GCF, that would leave me with x squared plus x minus 6. It still can't equal 0. Keep the x. Let's factor this by trial and error. And the last sign is negative, so you have 1 plus and 1 minus. We know it's x and x. I need factors of 6 that have a difference of 1. Difference because these signs are different. So how about plus 3 and minus 2? You can check that part with FOIL. Outer product is negative 2x, inner product is 3x. That gives me 1x. All right. I have 3 factors. I'm using a not equal to sign, but I'm doing everything like I did before. X cannot be 0. X plus 3 cannot be 0. X minus 2 cannot be 0. This is one of the answers. Subtract 3. X cannot be negative 3. Add 2. X cannot be 2. So as far as answering it, in the box, it says use a comma to separate answers as needed. You would put in 0, negative 3, and 2, and it does not matter about the order. So just as a recap, the domain of a rational, meaning it's a fraction, rational function, excuse me, the variable can be any real number, but it cannot be those numbers that make the denominator equal to 0. We're not worried about the numerator being equal to 0. We're only worried the denominator cannot be 0. Okay, you've got a few problems in your homework to work on.